Welcome, and our first flipped video is over equivalent fractions. So, in your table of contents, I need you to label. We will start with page 5 in your journal. So on your table of contents, we'll write today's date. So August 26th, we'll write page 5, and our title will be equivalent fractions. So you'll need to pause your video and write this in your table of contents. When you're filling out your table of contents, you do not have to write every page number. It's every time you need a new topic. So if we use page 5 and 6 today, you won't write page 5 and 6. You'll just skip to the next video or the next notes and put page 7. Okay? All right, so on page 5, give it a title at the top of your page, equivalent fractions. Okay, so the very first thing we do when we are writing our notes, we write our objective, and typically it's written as our normal standard, how it's written in our classroom, but this is not a 6th grade standard, so we wrote it in our own words this time. Your objective is to determine if two fractions are equivalent, and then also to be able to name other equivalent fractions. So when you're writing this, you pause your video, and you copy this down just like it is in your notes, or in your video. Then we write our guiding question, because this means by the end of your video, you'll need to be able to answer these questions. Today's guiding questions are: how do you tell if two fractions are equivalent? And how do you write an equivalent fraction? Meaning if you have one fraction, how do you come up with another equivalent one? Okay, so our introduction problem, actually I have 2 of them written down here, and that's okay. You go ahead and write them both. The first one is list the first 5 multiples of the number 6. And the other one is list all the factors of 24. So to do this, you need to be able to understand the difference between multiples and factors. We worked on this yesterday in class. So your multiples are skip counting. They're getting bigger. So when you're multiplying by 6. So it's as if I'm skip counting by 6. So it would be 6, 12, 18, 24, and 30. The factors of 24, it means telling all the numbers that will go into 24 evenly. Some of you call this the rainbow method. I'm not crazy about that because it makes it really hard with spacing. I usually prefer a T-chart. But it's up to you. It's just a matter of how you organize your paper. I like to write them in pairs so I don't forget any. So 1 and 24, 2 and 12, 3 goes into 24 8 times, and 4 goes into 24 6 times. You notice this column here is getting bigger. This one's getting smaller. When they've met here toward the middle, because we know 5 does not go into 24, so once we've met in the middle, we know that we have all of our factors. These are all 8 factors. It's not just one side or the other. Okay, the next part, rules. So we pause our video and write down the rules, and this is going to explain how to do some of our work for today. Two fractions are equivalent if it has equivalent cross products, or if there's a multiplier that works for both the numerator and the denominator. The cross products are always easy to do, but sometimes it's hard to see the multiplier, and I'll show you some examples of that. So you pause your video and write down the rules. Okay, so the first one here, number 5, we're going to do a few of these for the number 5 question. Okay, we're going to check, are they equivalent? Okay, and we're going to show you what both of these mean, because you can check both of them. One, the equal multiplier first. I'll do that. The equal multiplier means, is there a number that I can multiply both my numerator and denominator by to get this number over here? How do I get from 3 to 6? We multiply by 2. And can I multiply by the same number to get from 5 to 10? 5 times 2 is 10, so yes. If I can multiply both the numerator and the denominator by the same number, then yes, they're equivalent. Okay, that's the equal multiplier, or your scale factor. We're scaling up. Now, we also talk about cross products. Now, some of you may call it the butterfly method. I do not like using those words. It's not the accurate math words. And when we do that, we don't really know when to use it. So cross products mean I'm going to look at the numbers that are a diagonal from each other, and I'm going to multiply them. 3 times 10 is 30. Product means multiply, right? And 5 times 6 is 30. If these two numbers here are equivalent, then your fractions are equivalent as well. So number 5, I want you to show this right here, and then show how we prove that they're equivalent. But we'll show you a couple more. See, on this first one, the numbers got bigger. We multiplied. But are these equivalent? Is there a relationship? How do you get from 7 to 1? And does it also work from 21 to 3? It's not always just multiplying. It can be dividing. Okay, because if we look backwards at multiplying, we could. So 7 divided by 7 is 1, and 21 divided by 7 is 3. So these are also equivalents. Maybe you may say, oh, that's just simplifying a fraction. It is, but I know 6th graders struggle with that. But we could also do the cross products. 21 times 1 is 21. 7 times 3 is 21. These are equivalent. So 7 21st and 1/3 are equivalent. This is all still number 5. I'm showing you a couple different examples of the same type of problem. Okay, are these equivalent? See, I see 5 times 2 is 10 and 11 times 2 is 22. So does that mean they're equivalent? I multiplied by 2, but it's not. I have to multiply the numerator by something to get the other numerator, because that'd be tricky. We check our cross products then. 5 times 10 would be 50, and 11 times 22 is never going to be 50. Okay, it's going to be a lot bigger there. Okay, we have 232. Not the same thing. Okay, so this one is a no. Okay, and the last one here for number 5, are these equivalent? You say, well, 8 times what is 10? And 12 times what is 15? We don't see a whole number. So the equal multiplier here, scale factor, is really hard to see. There is one, but it's not a whole number, so it makes it really difficult here. So the best thing to do here, if you're not sure, you could either simplify this. So 8/12, they both divide by 4, and I get 2/3. So then I could check 2/3 to 10/15 and say, look, 2 times 5 is 10, and 3 times 5 is 15. That means they are equivalent. But if I don't think about simplifying, I could also still look at cross products. 12 times 10 is 120, and 8 times 15 is 120. Yes, these are equivalent. Now, how to write an equivalent fraction? It's easy. You just multiply both your numerator and denominator by the same number, or divide. That's be simplifying, right? So if I do times, I could do 2 over 2. That'd be 10 over 14. I could do 5/7 times 10 over 10. It would be 50 over 70. That's all I have to do is multiply both parts of your fraction by the exact same number, and then they're equivalent. Okay. I want you to give an example of this. 18/20. Give me an equivalent fraction here. So you'll pause your video and write an equivalent fraction. Okay. We're almost done. How to determine if the missing number, or how to determine what the missing number is in a pair of equivalent fractions. So I have 2 examples here. Okay, so I'll just look at the relationship between the numbers. How do I get from 2 to 8? Well, 2 times 4 is 8. So then 7 times 4 would be 28. So 28 is my number. Okay, this one's a little bit harder, right? I don't see how to get from 8 to 12. And I don't see a relationship between 6 and 8. So I can still do cross products. 6 times 12 is 72. So that means 8 times what is 72? That'd be 9. 8 times 9 is 72. Okay, that would be number 7. Okay, now we're about done. Okay, predictions. How is naming fractions going to be necessary when you have to add them? Why is it important that I can be able to rename a fraction before I can add them? I'll give you a hint. It has to do with the common denominator. I want you to try to answer that one on your own. Okay, number 9. What questions do you still have? Now, we have a rule about this. If you do not still have any questions, I want you to tell me, what do you think may be the most difficult part of this? Or maybe where do you think a lot of students may struggle? Or what do you think the common errors may be? You have to answer this. Okay, the very last thing is just give me a number. Rate yourself on a scale of 1 to 5, how well you understand it. Number 1 means you are totally confused. Number 5 means you know all of this so well you could teach someone else. Okay, that's all you have of your video. Have a great day.